Thank you. So yes, using Maple with Jupyter and Python, and I think I'm going to talk about Python first and then Jupyter, although all of these topics are really thematically related. Uh, excuse me. You may know that I won't. I think most of this audience probably is certainly quite aware of Python, and Jupyter I think has almost as high a profile. So Python is an interpreted programming language, which is the basis of many scripts nowadays. It's kind of displaced Perl as the sort of go-to interpreted scripting language, multi-purpose. So I think no more need be said. Early in Python's evolution, there was an attempt to add what's called a REPL-based interface to Python. So this was, I think that stands for read, evaluate. I forget exactly what the P stands for, but in any case, it has a certain kind of, it's not particularly important for our purposes, but essentially it consists of an interactive document with a number of input regions, not unlike what we've seen before in Maple and similar products, in which you execute serially a series of inputs, and then transform some kind of computation state that's associated with the document. And the document is typically mixed in with, it freely mixes computations with associated text or images that accompany the computation. So if you like, it's a piece of code embedded in a document. It's sort of primarily a document with bits of interactive code that execute. So that is a common paradigm that existed before. It was applied to Python, but it, I think, gained a lot of popularity with Python. So they created this interactive Python shell called IPython. And then when it became very popular, it eventually outgrew Python, was adapted and extended to support other programming languages, and was renamed and rechristened Jupyter. So that's why the two of them are very kind of appropriate to talk about in the same context. So without a lot of further ado, I will launch Maple. So the first thing I want to mention is we have a version of Python that ships with Maple and has done so since Maple 2018, I believe. It is used by a number of bits of Maple, most notably the deep learning package, which I believe my colleague Eric demoed briefly earlier today, and during his AI talk. So that's based on the TensorFlow package, or rather specifically the Python interface to the TensorFlow package. And so essentially it wraps certain functionality from that. So what we have, so the first thing I want to show is the kind of core level of Python and Maple. So with every Maple document, there's a Maple engine instance lying around that's the variables you have in memory and everything. And now, along with that, whenever you run anything in Python, there's also a Python state that is associated with your worksheet. So the sort of lowest level of accessing this is this Python package, which I think was added in Maple 2018. So you get you can have a series of commands that do that. I won't talk about this in great depth, but essentially here we're passing a string to our associated Python and evaluating it, and it's giving it back 2. So that 2, it's not rocket science, but that was actually computed not by Maple, but by Python. Similarly, you'll notice a couple language quirks which Python inherited, I think, from from C or other similarly low-level languages. So this is something that the mathematicians among us are maybe irks us, but the caret in Python is not exponentiation, but instead represents, I believe, an XOR bitwise operator. So you have to be aware of that when you're adapting code to Python. You have to use star star, which is also supported in Maple and has been for a while. So 7 caret 15 is this bitwise operator that and this is just a couple simple examples showing that you can call upon this version of Python that is bundled with Maple. And here we're just calling out to the statistics package in Python and doing some basic things. The key bit is that these objects that come out of Python that Maple has a handle on can actually be, to a certain extent, can be used like Maple functions and can be queried and passed arguments and this sort of thing. So in a similar vein, here we have a vol string math.sign. So we get this thing, PySign, which is actually a handle on the Python sign function. So again, this is, in a sense, offers a very small subset of the functionality of Maple sign function because it doesn't do symbolics. But it nevertheless is, you can see from this that you can do all the kinds of things you can do with any Maple function. In particular, you can plot with it. It will give you numbers. You can view them, and you can query it, that sort of thing. So that is as I say, the lowest level of access to Python. And then there's a number of other ways we've added functionality relating to Python in the last few releases. One of them that's kind of cool that I'll show you is the Python code edit regions. So this is something we added, I think, 2 releases ago. So you may know that in Maple, if you're going to have a bunch of code, perhaps defining a procedure or something that multiple lines of code, it's often advisable to put it in a code edit region, which you can create just by insert code edit region. I think there's also a way to do it off the components palette. Anyway, the code edit region is just a little text area full of text. Excuse me, and it can be conventionally in the past it was only allowed to be Maple code, and it would evaluate. So when you executed the whole worksheet, it would execute like any other piece of Maple code at the place where it occurs sort of spatially in the worksheet. So if this stuff, it would execute after the stuff that was just above it and before the stuff that was just below it. But it would be, it would be part of the same Maple session as the rest of the worksheet. But we recently added a new feature. So if you click into this code edit region that I have here, and you look over here on the right, there's a new as of 2023 attribute called language, and it can either be plain text, which means it actually is just nothing it's not interpreted by the Maple worksheet at all. It doesn't try to do anything with it. It just leaves it there. Maple, in which it tries to execute it as Maple code. That was kind of the first thing we had. And Python. So this is a nice way of dropping bits of Python code into your Maple worksheet, as it were, without having to deal with this sort of inconvenient API interface that you have here, where you have to throw everything inside the arguments to these functions from the Python package. Here you can just drop this in here. This could be a piece of Python code that you got off some web page or something, and then you execute that. So we execute it here. That will define not in Maple, but in the Python session living alongside the Maple session, this Python func, and now we can execute that. We can grab handle out and execute that, and it doesn't do anything particularly amazing, but it returns the identity matrix, and this is actually returning it from the NumPy package for numerical linear algebra within Python.
Stephen,
So,
would you be able to zoom in a little bit, make
oh,
the magnification factor a bit bigger?
sure. Is that better there?
One more step would be great.
Yeah. Okay.
Thank you.
Sorry.
That's great. Thank you.
Yeah, sure. No, I appreciate your the difficulty there. Right. So that's yeah. So you can see that this is much the same as you just enter Python code here, and much the same as you would inside inside Jupyter, which you'll see shortly. So a slightly more extensive example, which more non-trivial one. I'll just quickly do one. So this is we use a Python. I'll zoom in again. We use a Python package called Beautiful Soup, which is a standard Python HTML parsing package. And here, this is, I'm not going to win any awards for this parsing implementation. It was just something I whipped together. But essentially, it uses this to parse the code for the HTML schedule of this conference to determine what the sessions are for today. So it just tries to rip that apart using a bit of Python, and then store it in a variable called result. We then pull that result using Python eval string out of the Python and put it into Maple. And then you can see that the first talk today was by Laurent, AI in the End of Math as We Know It. And the last talk, at least up to this point, is this one. So so you can see this is kind of nice because this is pure Python, and it can be structured in however you like to structure your Python. So that brings us to, so that's kind of the first tier of my talk, using Python within Maple. And then the next topic is using Maple from within Python. And that brings me to Jupyter. So we don't need to use Jupyter actually to use Maple from within Python. You can maybe it'll just be helpful to show you that you don't need to do that, because actually, and as of Maple, excuse me, as of Maple 2024, can I make this bigger? Yes. I can type Maple 2024 Python, and I get a Python instance, and I can actually access Maple from that using the API I'm about to show you. Now I will go to Jupyter now, because this is a bit difficult to read. It's there's no formatting, and it's some would say it's a bit old school, but it's I just want to show you that Jupyter is not a necessary component of this picture. It's just one of the many ways that you can access Maple from Python. So without further ado, I'll proceed to Jupyter. And here we have, I actually had Maple 2024 installed. This is previously, this is 2023, but it's the same. So for the purposes of what I'm showing you, so I'll just leave it as that. But yeah, so for the first thing I'll show you is a Python notebook. So Jupyter has this interface here, which is, I think I described before, as having a series of input regions. And let's see, I think I've launched this from the wrong directory, because it's not giving me it's not launching it from where I want it to be. So I'm going to relaunch Jupyter from correct directory, Jupyter Lab, and there we go. Right. So so if I show you, for example, so here's a simple example which uses which calls upon Maple from Python. So this is a Python Jupyter notebook. You can kind of ignore this bit of code. This is actually I'll talk about this towards the end, but essentially this is just a bit of code to teach this Python instance where to find our Maple library, because we haven't as of yet added the Maple library to the Python package index. So you have to essentially explicitly teach your Python where to find it by looking for it within the Python that is shipped with Maple. But it's our goal that eventually this line will be redundant. So anyway, so typically these begin with this import Maple numspace. I think this we may change this in the near future for a certain reason, but we'll try and make it backwards compatible. So anyway, you import a Maple and Maple numspace. So this is and these are this essentially makes the Maple namespace available to Python. And then here, this bit of code is actually pure Python. It has nothing to do with Maple yet. It's just defining an array of 5 points, and then I want to query. So what I want to do is solve. Pardon me?
Once again, to zoom in a bit, Steve.
Oh, apologies. Okay, should be a little bit better. So we have here a series of essentially, think of this as a list of 5 numbers. So what we want to do is, using this Python interface, we want to invoke Maple, pass a differential equation to it, construct a numeric solution for this differential equation, and then sample using the numeric solution, sample the solution at these specified points. So this is a bit of a constructed example, but you could imagine a larger example in which someone made use of Maple in a larger computation. That's, I think, the main use case we're imagining here, where someone has perhaps a larger Python program where perhaps one that makes use of other Python libraries, special purpose libraries, or some kind of code that they might already have developed for another purpose, but they have then some computation that they want to use Maple for. So here we just have this. We pass these numbers in, these symbols in, so that we can now then refer to them without having to qualify them. That's just a kind of convenience. And then we execute this line, which looks a bit like an equivalent line in Maple, but a bit different too. You'll notice the equations are double equals, because that's how you write equations in Python. But you'll notice quite a lot of the other bits of it are similar. So in particular, you can do curly braces to denote a list and that sort of thing. So we build this structure, and then we solve it using dsolve, and finally we get back a solution object. So we can see we could convert this. The output is a bit unpleasant, but we could convert that, I think, to maybe we can. I don't know if this will work, but yes. Right, that's a bit more readable. So these are the sample points of, I guess, the first one is the value of t, the second is the value of the function, and the third is the value of the first derivative of the function at all of the sample points. So that's the convention of the output from dsolve. So this is just shows you how you could actually use Maple from within a Python program. And there's a number of cases where you might want to use that. So perhaps, as I said, you're already doing something in Python, and you want to draw upon something from Maple. I was doing a little experiment with comparing us to a competitor, SimP, which is also very popular, of course, from Python. So here are a couple of examples where, so if we open, here is this is both to show you some examples. You might say cherry picked, but in any case, some examples in which Maple can do things that SimP can't, but also to show you that the syntax that you use from the Python interface is actually quite similar between them. So if you wanted to adapt some code from SimP to use with Maple, it's actually quite simple. So here we define a symbol within SimP, and here we integrate. So this is performing an indefinite integral, and it when it eventually comes back, it will be still unevaluated. Yeah. Well, at least it's not Maple that's stalled. Right. So, all right. Well, maybe I won't wait for it, and I'll just talk through the other answers, because the rest of the output is already there. So this is essentially a rational function, or here, and with a radical sign, and it comes back essentially unevaluated. If you do the same thing to Maple, it gives you back this hyperbolic arc trigonometric function. And then a similar example for a definite integral was the absolute value of this sine of x squared, which gives you this result in SimP, and then this result in terms of the Fresnel integral in Maple. So yeah, I think I'll for want of time, I will jump further ahead to the topic of Python. Excuse me, of Jupyter within Maple. So what I've been showing you is using Maple within a Python session, either within a Python session, it could be part of a script, it could be something a human never sees, but in this particular case, it's part of this Jupyter interface where you have this interactive document. Well, wouldn't it be nice if we didn't have to transform our code into this Pythonic form? Maybe we want to actually write in Maple, because that's what we're used to using, but we want to also still use Jupyter, this interactive environment, which has all kinds of nice features. So here is a this is so if you'll notice here, and this thing up in the upper right, you can select a kernel for each worksheet, and I've provisioned this kernel with a number of there's two options, basically, Python 3 or Maple 2023, and I could add 2024 too. So this worksheet is set up to work with 2023. So in this case, these input regions that I was talking about before are no longer Python. They are actually pure Maple, and you can do everything that you would do in Maple in them. Now the text of the worksheet is still a Jupyter document, so you can use stuff like this is actually Markdown syntax, or it's basically LaTeX or LaTeX. So you can interweave LaTeX or LaTeX and Maple input within this document, which is, I think, convenient for those of you, and I suspect there's a lot of you who are familiar with that. So this is just some content talking about Taylor series and early calculus, but the main point is that you can execute all this content in much the same way as you would within Maple. It will show you stuff like you would see in Maple. So here, there's the Taylor series, Taylor approximation, another Taylor approximation about, but it shows you a plot. And the further on, it will show you these are these function charts where you see where it has arrows indicating the regions of positive negative sign and increasing and decreasing positions on the function. And our colleague Rob Corliss has actually done quite a lot with this new Python Jupyter. Sorry, excuse me. This new Jupyter interface to Maple. So some of the examples that he's prepared are quite nice in the way that they make use of the visualization tools inherent to Jupyter to give a really nice exposition. So this is one about that he put together about continued fractions, where you can see these. This is a Maple illustration, but you can see that he has continued fractions using the LaTeX formatting for that, and you can generate them dynamically and build your own. And similarly, there's a lot else you can do. I think this is another nice one. Companion matrices. So this is again, it's mostly just there's not a whole lot here that Maple couldn't render almost as well, but it's still a very nice exposition and a nice presentation in a form that someone wouldn't even need necessarily Maple to view. You could view it using just Jupyter, even if you don't have a Maple license to evaluate. So that's maybe an important topic. The Jupyter interface is designed to execute a Maple session on the same machine. So your Maple and Jupyter have to be installed on the same machine. That's and yeah, although though it is accessed via a web address, so I guess you could serve it locally. So at this point, I think I've shown you, I think, a good glimpse into the two kinds of the Python and Jupyter, using Python and Jupyter with Maple. If there are any questions, I'd be happy to entertain them.
I'd like to pose Robert Lopez's question. He asks basically why. In other words, does Python have functionality that Maple itself does not have? Do you want to say anything about that?
Yeah. So Maple is a multi-purpose programming language, certainly, but there are Python. The Python community is very, very large and larger than ours is, and that's, I think, fine, because many of those people will have interests that don't necessarily touch directly on our core roots, which are computer algebra and related topics. So there are many special purpose libraries out there that have been implemented in Python, and it would be it's always possible for someone to implement something like that in Maple, but as a matter of practical necessity, it seems less likely that would happen, or at least it seems so much easier to provide a wrapper around some of the existing high quality ones that are already out there. So I think there's if we can interact effectively with the Python ecosystem, then there's no need to imagine someone having to implement the same thing in both places.
Would you say that the Beautiful Soup library would be an example of that?
Yeah, so I don't know that I don't think anyone would ever probably. It would make sense to write a web parser, an HTML parser from scratch, for example, in Maple. You could, and we did, I think, in the first version of going way back. We had not a web HTML parser, but we had some essentially something equivalent of the curl library, so for fetching web pages and stuff, and we implemented it ourselves in a low-level way. But that was because that was a long time ago, and now there are high-quality libraries out there that we can draw upon, and I think it makes sense to draw from that common pool.
I wouldn't mind interjecting here. I think there's a few things being conflated. You can access Beautiful Soup and these Python packages from within Maple. So I think the crux of Robert's question was, why use Jupyter? And I think the answer is you would only use Jupyter if you already were using Jupyter and that's what you're familiar with. Otherwise, if you're a Maple user and you're using the Maple interface, that's going to do more, and it's going to be more tightly coupled to Maple development. For example, you can't enter 2D math in the same way in Jupyter as you could in Maple. There's going to be a lot more features inside Maple that just make it easier to do Maple. But if you're starting from Jupyter, then let's support that.
Great, that's an excellent answer, Paul. Thank you. I think we've gone 2 minutes over time at this point, so we should probably end it here. I'd like to thank everybody for joining us on this first day of the Maple conference. We continue again tomorrow morning, at least morning in the EST time zone, at 9 in the morning Eastern Standard Time, with 2 sessions of contributed talks, algorithms and software, and Maple in education. Hope to see you then, and thank you all for joining. And thank you to the presenters as well.